Hello everyone. It's nice to have you on board, and we're starting off with knowing the Tinkercad environment, which is very important for you before you get started. This is a raw view. This entire view is a raw view of what you see on the Tinkercad environment, unlike what we had in the lab. And in the lab, we used physical components. Here on this environment, we have several components that we can use to create several projects. You're not limited to the components you have in your kits. You can learn and create several projects on this environment using your kit. So I'll take you directly. This is your component section, and this is the basic components. And if you scroll here, you see your resistor, your LED, push buttons, potentiometers, which you're already familiar with. These are new ones you're yet to know. The slide switch, and you have con batteries. So you can see that here you have several batteries to work with. You know the 9 volts battery, I've shown you that. And you can see there are more batteries here you can work with, and you also have the Arduino that I told you about. You will have a microcontroller for free. So you have your breadboard here as well. So this is the environment where you can pick up several components. I don't be scared. I expect you to browse through and check up all of these things. Well, it will be good to follow the guided activities which you'll be seeing on your dashboard. And those activities have been created, and I expect you to tinker with it. Once you check off the activity, you can tinker with that activity, or you can create, and then don't forget to save your work. Whatever you do here, I can view it as the instructor. We have 2 more instructors that will be coming in, and they will be working alongside myself to help you go through these aspects. So I'm here. Here is where you have most of your work done. You have let's just get started. Let me show you how simple it is. Now we want to create an LED to light up. We are starting with the most basic example so that it builds a foundation for you on this environment. Then we can proceed further into more complex projects. You see, I'm scrolling down here and I am picking up my breadboard. Now notice what happened. All I did was to make a click, and it appeared here. And once you come into this environment here, you can see as I move my cursor, my breadboard is working. So I just place it anywhere and just click on it, and that is it. This is what happens. A bar comes up showing me breadboard small, and then it gives a name. You can give a name to your breadboard if you're doing several projects on the same environment. But for now, I will not bother myself with the change of name because I'm working with only this breadboard. Now we are going straight for our LED, and I'm going to click here, and once I do that, you see it moves. It just moves over, and then this is how we place it. You can see I'm just moving up my LED, and my you can see the holes are pointing out however I want it. I can place it outside the breadboard, I can place it here, but I'll go right away to place it here. So let's work with this environment. Remember, your cathode and your anode, it makes it easy because once you navigate, you can see cathode, which is your negative, and then your anode, which is your positive side. Always remember that, the longer legs. And so I'm going to put it right here. You can make mistakes, don't worry. Once you make mistakes, you can always correct them. So I'm going to behave like a learner and teach you how it works. Now we put in our LED, and then the property for LED just automatically comes up. You can see the name. I can just leave it at LED1 since I'll be working with just one LED. Now you can change your LED. This is red. I love blue a lot, so I'll go for blue. You can go for any color, but once you click on it, you can see that it's changed already. So I'll be working with blue, and I expect you to work with several colors. If you want to follow my way, please, I'll be glad to have you on. And now remember we talked about the resistor. we don't want our LED getting burnt. Well, this is a simulation environment. It won't get burnt, but when the voltage, it expects that you are working as if you are working with physical components. So we go by the rules, right? So it's still important that we have our resistor, even if you're not burning up a physical LED. Now, I'm sure you've heard of astronauts, you've heard of um, what they call them now, the people that fly planes. Sorry, it just skipped my head. And pilots, yes. So you've heard of pilots, and then most times they don't start flying on air, live planes. They have to go through a simulation flying program in a big wide room where they enter a plane and then try to fly that plane like they were actually flying a real one. Then you see lots of environments where you could go through a storm, fake environments and all of that. And then these students are taught to navigate these things before they go in onto real life planes and then fly and not just kill themselves. So this is how it works right here. If you can understand this environment and work with these components, I tell you, you can do the same thing on your physical components. So for those of you that have physical components, you'll be working after you have created on the Tinker environment. Once you have done your creation and it works, then you pick up your kit and try to do the same thing and see if it works. I promise you it will work if you have already started here. So we are going right away and we're picking up our resistor, and then once we pick it, okay, so you can see once I click on it, I come here. Remember, we always connect our resistor to our long legs, which is our anode. And so my resistor is quite a big one, but I'll leave it. No, I don't need to leave it this way. See what I will do. I need to rotate it. So watch me. I'm going to just drop it anywhere here, okay? So we come here. Do you see the rotation sign here? All right. Now you can rotate. Do you see? You click on it, it's rotating to whatever position you want. But because we are working on the breadboard environment, we need to make sure they are both connected to pins. Alright, so now you see it's connected to a pin, but we don't need that pin there. We'll take it right to the leg there where we have our long leg. You can see our resistor is connected to our anode. Do you see? Okay, so this shows you the bus. This is a bus line for each breadboard, and it shows you how the breadboard is connected. So when I come here, do you see the green line? It shows you that the entire row is connected. So whatever you put here will be connected to your resistor. So we've done that, and then so far so good. We need to get our batteries, and then let's see how we light up our LED. And remember, LED flows from the battery to the other side of the into the circuit and then returns back to the battery, right? Okay, so this is the environment. Let me show you here where we have our positive power rail, where we bring power into the entire breadboard. On this part, not here, this part takes care of this entire angle from 1 to 30, while this roll here, the negative and the positive, takes care of any work, any project or any parts you put within A to E. So we are on A to E. Don't expect to power this area and then expect it to power on A to E. No, when you power on this area, it will be F to J that would receive the power. So I hope you understand where we are working at. If I ask, where are we connecting? Okay, I guess you're getting it. We'll be making the connections right here. Okay, so but first, before we do that connection, we need to make the connection right here. So we'll take a wire which is called a jumper wire. Let me show you where it is. This is where we have our colors and all of that. So we don't have jumper wires here because wires are not components. They are all here. So we'll pick up our wire. You can see our wire type here, and then you can see the normal hook, alligator, and all of that. But so for now we'll be working with the normal one, and then we're working with green right here. That's fine. So or we can take it over to red, and then once we do that, what we can just see what I do. See, there's no wire showing, right? But don't worry, we have selected, and we just come right here and see what happens. Do you see that? This is awesome. Mind you, we're taking the connection to the positive rail, so I just click on it. Do you see what just happened right there? You can try it all over again. If you do not understand, or you have placed it on the wrong part, you can always take it away from where it is. Now I'll just give you an example. Here you can see I can move it, I can stretch it out just like the normal physical wire that you have, and I can put it back there. If I don't need it on that part, I can come right here, and then I can take it. Okay, sorry, I'm creating more wires, so I can click a delete. I just deleted by clicking Ctrl Z, or you can go over here. Once it's toggled, you can go over there and then delete. So I'll delete it for the sake of showing you how it works in. You see, so this is how you delete components or wires from your circuit. So we're going to do it again. Listen and pay attention. Now I'm picking it up from here, my normal wire, and then I'm going to connect my wire from my resistor to my positive rail where it should get power, right? Remember, we are not to connect our batteries until we finished our circuit building. So this is where we are, and you can see I just clicked. I'm going to click here, and it tells me I'm putting up a wire. It takes me down to where I need it. Remember, I can always put my wires on any part of this positive rail, so it doesn't have to be a straight line. So I'm going to put it here because I just love to put it here. And we are also going to make a connection on this part here. Remember, your cathode will also need a negative connection. I told you about open circuits and closed circuits. Now if electricity flows from the positive to the negative, we must have a negative connection on our cathode. In case you forget the names, once you go close to your LED, you can see the names there. So I'll get one wire again, but I don't want a red wire. I want a black wire that signifies a negative connection. So here on the Tinkercad platform, it's beautiful because you can use actual wire. Sometimes on your kit you exhaust your red wires and black wires, which are very important. You can use any other wire, but I always love to stick with the red and the black when it comes to points of connections and all of that, so that you understand. Okay, so I'm not short of that here. That makes it very beautiful for us and for other learners who do not have keys. So do not be discouraged. This is your learning environment. So I'm going to take this, but before I do that, I will change the color, and I want a black one. So you see it's changed. Remember, you don't just put your hands there. You must click, just one click. You tap, and then you pick it up, your normal. And remember, we are on cathode. We are not going directly here. We're taking a step further, and we are taking it where? Oh, you can see something just happened. Our red cable just changed. Okay, I think because that was still selected, but we can work that out. So you can see I have my black wire already, my jumper wire connecting my cathode to my negative rail that takes the current back to the battery. So the mistake we made here, let's correct that. It's beautiful for your learning. So I click on this. You can see the two dots letting you know that we are on this wire, and I can change the color back to my beautiful red, and ta-da, you have this. Isn't it beautiful? Yes, so this is a circuit reminder for the first program we ran in the lab. And some of you forgot, and then we didn't have materials, but right now you'll be having materials. I promise you that. And on your platform, on the WhatsApp platform, you can see materials already there. So you can download these materials on PDF formats and then read through. So let's get started. Now we want to get our batteries. I'm sure you know what I'm going to do. You pick up your 9 volts battery. Yes, you can take several batteries. I know some of you are already thinking, oh, do I take this battery? Do I take this one? Yes, you can take these batteries and they will work perfectly fine because it's just a bulb. So, but for the sake of practice and reminder of what we've learned, we'll take our 9 volts battery. So I'm going to place it anywhere here. Now you see my property comes here. I don't need to change that. Remember, this is my positive and the negative side. So the positive goes to the positive rail and the negative goes to the negative rail. So I believe you can do that. Let's do that together. So I will take positive and I will go connect it right here. Do you see it's automatically showing the red wire? Now I can also go here, but because I don't want you can see because we're already on our red wire up. So don't worry, let's just put it here negative. We're connecting here, and then we can go right away to change the color, just to show you how it works, just to clear off the confusion. You can put blue for blue, but don't get confused. This black and red signifies the positive and the negative, and I'm working that same way with the battery so that you can understand how it works. You can use a yellow jumper wire here to connect to your black negative. This is just to make it very clear for you. So you can see we are all connected. Our flow should work. But how do we know if it's working? You say, oh, it's not lighting up. Don't worry. This is where you light it up. On this section here, you see start simulation, and you can press your space bar, or I'm going to use my pad and I'm going to just click on it. Awesome. Do you see? Do you see? Look back again. You can see my light here is showing here. You can see, let's stop it. Watch the LED light. Watch it. I need you to watch here and while I put it off to let you know if it works. Here also shows your simulation time. Okay, so now I'm going to stop it. Do you see? My LED has turned off, and you can see. Now let me start it again. Once I start, do you see? So it means our circuit is working properly. Light is flowing from the positive into the resistor. It's flowing, yes, and then going into the anode, into our LED, and then returning back to the battery from the cathode through the cable and then wire, and then back to our 9 volt battery. Isn't that awesome? All right, so this is beautiful, and then we can also always stop the simulation and then continue. If you want to change your LED even after running the simulation, you can still do that, and then you can put the red all over. There was something we didn't talk about. Now you can see I just clicked on my resistor. Resistor shows me the resistor property. Remember, I used 220 volts ohms, I mean, for my first resistor when we had our practical. Here this is 1K, so we're going to change it and see how it affects the light. Remember, this suppresses the light, so let's use ohms. This is ohms, right? And this is kilo ohms. So we're going to use the normal ohms, and then we're going to put it at 220. So you can see it's at 220 right now. Do you see that it changed the property? 220 most times is usually 2 reds. Okay, so just take note of these things, and let's run this simulation again. You see? Do you see? So it's lit. It's already lit up. here. Now you see how wonderful it is. All right, so let's stop this simulation and then let's change our resistor again and put a lesser value for a resistor. Now if you check your kit, you have 22 ohms, you have 10 ohms, you have 10 kV, you have 100 ohms as well. For those of you with physical kits, is practically the same thing. We'll be doing that. You just need to change the value and you get to see how resistors based on their sizes control the amount of light that flows into your circuit. Now our resistor is protecting our LED, so the amount of light flowing into our circuit is determined by the value of our resistor. So we use 20 and 220. Let's use 100. Let's see if our light gets brighter or it's just the same thing. So we are taking 100 ohms here. Great. Now you see it's all saving. Your work is automatically saved because it's online, and we are going to run this simulation again. You see, so you can see if you click on your LED, it tells you exactly what current is flowing through it. You see, it's a current through the LED is 65 ohms, while recommended maximum is 200 mA, meaning for the maximum we have 220, so we can have higher, but we have a particular voltage that we can use for this LED. So if we use lower voltage and the bulb gets too bright, it reduces the life of our LED. That is what it says below. The usable lifetime of the LED may reduce. So we are being warned that 100 volts is too low, and so we should get back at least to 220 volts. So let's see the current in let's see the current flowing through when we change it to 220. Okay, now we have 65. Okay, so let's just click on it again and then we change it over to 220 and let's run our okay, sorry, we didn't stop the simulation, so that change did not. Okay, let's see. Okay, I think we're already on 220. Let me start the simulation all over again. And yes, so it's changed. You can see current through the LED is 30 ohms, while recommended maximum is 20 ampere. That is what you have, the mega ampere, that is MA. Don't worry yourself too much about it. Now this information is just showing you that it is actually working. Our resistor is actually doing something. It's not just lighting up our LEDs, but you can see the current that is flowing based on the kind of resistor that we use. Now you can try without a resistor and then see what happens. It mimics our physical environment. So this is our first startup program for today, our first activity. I expect every one of you to work on it. So it's not like the lab where we didn't have enough kits. Everybody here gets to own their breadboard and own this environment. For children using one laptop, I would advise that each child works individually. You do your work, you save, then you log out here, and then you allow your sibling to come in, log in into their own environment with the code and your nickname given to you. You work on that same environment and then you save your work. I will see it from my own end, and you log out. So you just bear with mommy and daddy until you're able to have your very own laptop. So that's it about it here. Like I told you, you can always delete, but you see our delete is not working here. Here shows you to undo, meaning you can go back to the previous activity or previous a move you made. Okay, so when you do something you don't want to type Ctrl Z or delete, you can just come here and then delete. You can copy your project. You can write a note here. If you click on it, you can write, say this is an LED. Let's do something like that. So I'm clicking on it and I want to put a note. Okay, this is to make my note visible. Now, good. I was waiting for it to come, so perhaps I had a little network glitch. So this is my note here, and you can see write a note. So I can just write something. This is a simple project. It's not aligning properly, so so we can okay, all right, so let's write it up, then it aligns on its own. So we write, this is a simple project, okay, to light up an LED on the Tinkercad okay platform. So I go out and you can see it's already aligned. So what I just need to do is make sure my hand is showing there, the hand sign. Then I can you can move it around. You see, we can move it here. Okay, all right, so this is how it works. So once you come in here, you can see this activity here. And so when I run again, it doesn't affect my work. It's working. So I want you to scroll through this environment. But one more thing before I go, for our senior classmates that are curious to know, you can see basic components here. Once you click on it, you can have all components. And when I click all components, it changes the entire component, meaning it adds more components. I'm sure you've heard of resistors and the rest. So you can see ultrasonic sensor, which we said we'll be using for our dustbin project. You can see PIR sensor, which checks motion. So you can see a whole lot of components. You can see digits for those that want to build up clocks, or you want to create a simulation of the traffic lights showing the number of time, like 60 seconds and all of that. You can use this. We can use this to also create our robot car. So here it's not limited to just building on circuits. We can actually build several projects, simulate several projects, build cars, and all manner of projects. You can try them here before you try them on your real life kit. So this is what you get when you click all component. But I advise you that for all starters, just work with the basic. Now you see starters here. This starter shows you basic, like we just have here. Then we have Arduino. You can see microbit. I'm sure you've heard of microbit. Microbit is a controller made by the microbit organization to help learners learn to program and do other things. The same thing with Arduino. So meaning in the course of learning in the STEM club, you also learn to write programs using the Arduino and all of that. So when you click on Arduino, everything about Arduino comes up, your first Arduino programs. And I said you can always purchase it by yourself, or you can reach out to us or through the school and we'll help you get one. But for now, we advise that you learn to use your microcontrollers here on the Tinker platform. And once you're good with that, you can build up, and you don't need money to do that. All you just need is a stable connection and an internet access to help you get started. So you're not doing anything now, but you can see a lot of projects already done. And when you click on it, you can bring it onto this environment. But we are not doing that. You need to clear up space for that. So we're going back to the basic, and then it takes us to just the basic components that you'll be using on this platform. So please go right ahead and then begin to tinker, begin to work on projects. And let me show you something on our breadboard. You can see we have big breadboard, so you can always bring several breadboards and then save them somewhere, and then you can work with several breadboards and do the same thing at the same time, maybe different projects on this same board. So but we are not doing that. Yeah, we are going out. So that is what it's like. All right, so I wanted to show you something, but I'm not seeing it right. Let me see. Okay, no, it's okay. It's not there. Okay, I'm just trying to show you something. Um, okay, great. So this is what I was trying to show you. On when we click on all components, you see we can see big breadboards, we can see small breadboards, and we can see very mini breadboards, all of which I showed you when we met. You can always click on them, and then you can see the kind of breadboard that you have in your kit, which we used in the lab, and you can place them. You can use this instead of the smaller one we used. So since we are not using this, we can always delete. And this is our mini breadboard, which is also available in the market. It's quite cheaper than other ones, but you use them for specific projects. You cannot, because of the little tiny bus rails, the same rails, but we have short smaller rails, so we can work several projects. But you can use this for specific projects and still simulate this all on this aspect here. So that is how we go about it. So far so good. We have come to the end of this um lesson, and I just need you to go around your Tinker environment. That will be your first project today, knowing and studying the environment, and then setting up this project right away. Like I told you, you can make mistakes, you can also make corrections, you can always move them, and it still runs and works very fine. Okay, don't forget to stop. Now when you need to send your project, you can share with people, you can even share with friends. We have friends around the world. You can share with your friends in the US, you can share with friends online. Once you click on share, you have several options. You have picture of your design. You can download it and share it on the platform. I'd love to have it there too, so that I know that you're really following this. So once I click on this, it goes directly to my download, so I can view it there. You see? All right. And so this is the several ways we share. For those of you already on Autodesk Fusion, those are already creating a lot of projects on 3D. You can do all of that, or you can share it by email, or you can also invite your friends, friends from anywhere around the world. What you just need to get their nicknames, and you invite them. They can get to see these things. Now permit me to let you know that the Tinker platform is not limited to your own environment. You can always browse through the Tinker platform. I advise you to do that, but don't get left out, don't get lost. You can go out of your environment and then see several projects developed by other people, newbies, experts, and all of that. So once you are logged in, you can see their projects, you can remix it for yourself, and you can save it and do something better with it, or degrade it. So it's a beautiful environment, and it's lovely. Please send comments and questions. Today we have our um instructors that will be taking up answers questions today on the WhatsApp platform. You can still send informations also at any point in time, but you will not get a live an immediate response outside today, but we'll be responding. I'll be doing my best to respond within the week. For some of you that can log in, fine. Reach out to your friends, tell them we've started. Always use the WhatsApp environment, and we are good to go to get information. Thank you.